Hello, and welcome to a brief tutorial on installing mTree and having some initial auctions run. In order to install mTree, what you'll need to do is actually pull down a repository from GitHub. We'll be using that throughout the semester to maintain code, and when we run into problems, if we need to make any code changes, we'll put them there, and then you'll be able to update the code and then hopefully continue on your merry way. So we're going to quickly go over the two repositories you'll need to download or clone to your local computer. So this tutorial will be principally focused on Macintosh computers, and then we will eventually add a Windows tutorial as well in the coming week or so. So the first repository you'll need to get is the mTree repository. So if you go to github.com/gmucsn/mTree, you'll be able to get that code. And then if you're not familiar with it, you'll simply go and type and hit the code button to the right here, and then you can grab the clone location. If you hit the clipboard, it'll copy it to your clipboard. So once you have that, then you'll switch into the terminal utility in the Macintosh, right? This is just like the command prompt in Windows. You'll go to Applications, Utilities, then Terminal. Once you're there, I'm going to assume you have Git installed. If you need help installing Git, please alert the instructor, and then they can point you to appropriate tutorials. So you'll do a Git clone on that. So it's pretty straightforward. So you type Git and then clone, and then you copy the link. And then additionally, we're also going to both the mTree location and then the auction examples. So if you go to auction examples, you'll be able to grab that code as well in the same way. Copy it, copy the link, Git clone, and then just paste in the link. Okay, so now once you have this, you will have to go into the mTree repository, one, because you need to install it, but then two, we're actually operating on a different branch. So there's in the world of code control, source control, there's different branches to maintain things. So we're only using one branch for our most up-to-date changes. So you'll want to ensure that you're on the appropriate branch. So we'll do that now. All right. So now what we're going to do is we've cloned the two repositories for mTree and for the auction examples. And so now what we're going to do is go into the mTree repository to pull the appropriate branch down. So we'll switch into that directory, cd mTree. Obviously it is case sensitive. And then what we'll do is we'll do a git checkout -b builder step 1 origin / builder step 1. And what this will do is it'll track the remote branch. And so this is basically, so whenever we have updates to the mTree code, you'll be able to pull those, and it should work rather well. So what we have to do next is to actually install mTree. And so we'll do that by typing in python setup.py followed by develop. And then this should install. Some of the packages will already be available. If you do run into problems after this, again, let us know, and we can make some changes to get things to work. Okay, so now what this is telling us is that we have mTree installed. So what we can do is we can actually start to go and try to run an example. So the examples, if you recall, are in the mTree auction examples code. So we'll switch to that directory here, and we'll come back in a second. And we'll show you how to use this. But let's change and look at the auction examples quickly. So the auction examples, this is if you download the mTree auction examples, currently that'll have an example of a partial example of a sealed bid common value auction. So this is a particular folder structure. You will get used to it over time. So you'll have a config file, or config folder, and then a config file inside of it, which is JSON. So in the config file, you'll have the type of configuration it is. In this case, it's a simulation description. You can give it whatever name you want. You can give it an ID you want. This is the ID and name fields are principally for making it easier to look at your output. What you will then do is in the environment and institution, you'll type in the name of the class of the objects that you want to serve as those in the microeconomic system. So CVA environment and CVA institution. In this case, we're only going to do one run. We'll play around with that property in future videos, perhaps. And then with the agents, it does look slightly different. It ends up being a list because the agents are kind of where a lot of the work gets done. And so you can have multiple agent types in here, and you can have multiple agent quantities, right? So you could have, in this case, we have CVA simple agent, and we have 5 of them. In other cases, you might have 4 different types of agents and have different numbers of them. You can also put in properties, and so we'll show you how these sort of get percolated through the system and become available. So in this case, we set an agent endowment, which we'll make use of later. And then now that we've looked at the config file, the next set of files we'll actually look at are in the MES folder. And in this case, we have 3. So in CVA environment.py, CVA institution.py, and then CVA simple agent.py. So what you'll notice in these cases is that they are relatively simple Python classes. There are some stuff commented out here. We'll be updating those back and forth in the coming days. It shouldn't affect what you're doing, and we'll update the examples to reflect some of the code-based changes. So what you'll notice is you'll define a class in Python, and then for it to be kind of part of the MES, you have to put what's called a decorator at the top of it, or right above the class. In this case, it's a directive-enabled class. And then what this means is that it will handle certain types of messages and operate in particular ways. We have an ability to have expected properties. It's not set up for that at the moment, so we'll provide an additional tutorial to discuss how to use the expected properties capabilities, which is useful if you're trying to run a lot of simulations at once. So then what you'll notice inside is you have methods as you would in a normal Python class, but then in this case you have these @directive decorators with a name. So what this is actually saying when this actor in the underlying compute system receives a message that's called or has a directive start environment, it'll actually go and it'll execute this method, and so it'll provide the endowment and start the auction. And in this case, to be clear, the start environment is a system-provided event. So the idea is once the MES is configured, the system automatically says, let's start the environment up. And then the environment reacts and then distributes property rights and what have you, and tells the institution about the agents, so on and so forth. So that's what's happening there. And in this case, we're going to provide the endowment and then also start the auction. So if you look down to this provide endowment function, we have an endowment of 30. Notice we're not, you can change the variable here. We could set this as a property, but for the sake of illustration, we're just doing it this way. And then in this case, what's actually happening is you have there's some internal properties that you'll be unaware of. You'll be able to browse in the documentation. But the agent addresses are all of the agents that are associated with a particular microeconomic system. So these would be all your subjects, for example. So the environment already knows about those. So you can iterate through them and then send each of them a message. So you'll use this message class, and then you set the sender self.myAddress. Whenever you need an address, this will be something, we'll be changing this, but frequently when you run into errors, it normally is actually a result of issues with certain types of data like this sender address. Then in the message, you'll set a directive. So just in the same way that this directive start environment was handled, you could actually put the directive into the message, in this case, set endowment. And then you'll give it the message a payload, so the endowment itself, and then we send these off to all of the agents. Once we're done with that, right, then we'll actually go to the start auction. So we'll create a new message, but instead of sending it to the agents, we're actually going to send it to the institution. And again, you're just creating a message and sending it, so it's actually fairly basic. One thing to keep in mind is where we have the agent addresses, those are a list. We also have the possibility of having multiple institutions. In this case, we only have one institution, and so we can access it by self.institutions square bracket 0, which of course is the first element in the list of institutions. We only have one, so that's what we're doing here, and we're just sending a message to the institution, hey, go ahead and start the auction. And notice in the payload, we're actually sending it the addresses for all the agents, because the institution starts and it's it's aware of the environment, but it actually is unaware of the agents until you tell it. And this can be useful, especially if you have multiple institutions that might only need to know about certain agents. So now we'll quickly look at the institution code. So this is, again, it's a directive-enabled class. We set up some initial properties. We'll talk more about those in future videos. We have a couple of random directives, which we're not going to really spend too much time on. But then what you'll notice is that we have a decorator for start auction. And then we have a message schema, which will specify the fields that you expect in the message itself. It's not enforced right now, so that's just an expectation. So we would be able to document what's going on in the message space. And then we also have a message callback, which is not fully utilized here, and we'll explain how those operate, again, in future videos. So in this case, what's happening is we're telling the institution to start an auction, and then what it's going to do is it's actually going to look to see how many auctions it has to run. If it still has more than 0 auctions to run, it'll go ahead and try to run it. And then what it'll do is it'll pull out the agents, it'll set those up so the environment says, hey, here are the agents participating in this auction. It'll initialize a list to contain all the bids. It has some idea of the bids that are outstanding. So in this case, right, if you have 5 agents, then you have 5 bids outstanding at the beginning of the auction. And then in this case, it's a common value auction, so we randomly select the value for it, and then we want an error signal for the agent, so we draw a random sample for the error on the auction item. And then what we do is we actually we're going to send each agent information, and so in this case we're sending them the value of the auction. Again, it's an estimate. And so what we're actually doing in this case is we're taking the item for auction, so this is just a value, and then we're subtracting the error off, and then we're actually sending that to the user. So this is actually, it's just selecting a value between the point estimate for the value and then the error upper and lower bounds. Again, it's a common value auction. It's not particularly complicated, but again, this is just one way to write it. Then we send the messages off, and each agent then gets slightly different values for it, and also it knows the error. So if you look at the payload, right, we have the agent value and then the error for the auction. Okay, so once we have that, then this is actually going to the agent. So there are different ways to look at this. So what we're actually going to do is we'll jump to the agent class. Again, it's a directive-enabled class. We have this init agent. Again, these are some internal stuff which you don't really need to focus on. And then what you'll notice is the item for bidding, right? So in this case, what's happening is it's actually receiving a message from the institution, and it's actually going to make a determination and respond and make a bid. Again, in this case, it has the message callback. We're not going to wire that and show it to you, although it is technically there. We'll talk about it later. But the expectation is that the schema of the message should include a field called value. It should also include an error, but again, we're not enforcing this just yet. So the item for bidding comes in. We pull out the value field. We also record the institution because, again, there's a lot of address management here, and so it's just aware of which institution originated the item. Then in this case, we actually have 2 different log capabilities. So you can actually use this logging.log. That's not the preferred method. It doesn't really matter, but you can actually do self.log experiment data, and this will actually create the log messages that you'll eventually retrieve. And then finally, after because again, this is a computational agent, so it doesn't need to wait in this case. So it's actually going to immediately make a bid. It makes the bid by going down to the self-make-bid or make-bid method. So it creates a new message, sets the address for the agent, and then it puts together a directive, which is bid for item, and then the item for bidding. And so what it's actually doing, right, is it's just paying whatever the bid is, whatever the value is, right? So it's very straightforward. And then this goes back to the institution, and what we have is we go down to the directive decorator for bid for item. We see that it goes to the accept bid method. We pull the sender information because, again, we'll need to figure out which agent won. We'll get the payload of the bid. We'll append that to the list of the bids. In this case, what we're doing is we need some way to store it. So we have a simple tuple, which will include both the bid and then the agent bidder that made it. So we do that, and then what we have to do is just record how many bids are still outstanding. Eventually it gets to 0. Once it gets to 0, we're actually going to declare that the auction's complete. And then we'll actually run the complete auction method. Again, there's no directive that needs to be fired to complete the auction because the institution itself is now aware that all agents have bid. And so what it'll now do is it'll sort the bids out and try to identify which one is the top bid, and then it'll identify the winner, right? So in this case, you sort it, and then it's a reverse sort, right? So that it's descending. So the first element is to be the winner because that's the highest bid. Then we create a message. We send it to the winner right here between line 77 and 81. So we just tell them, here's what you won the auction, and oh, by the way, here's the real value. Okay, and then the other agents right there, losers. And so as a result, we'll tell them that the auction is over, right? So there's an auction result, and they are in fact losers. And so they'll be aware of that. Which again, if you wanted to have a reinforcement learner, then the reinforcement learner, for example, might increase its bid or something. And then after that, right, the auction itself has ended. And so in this case, what we're actually going to do is we'll send a message to ourselves, right? So in this case, we're telling the institution, hey, let's go and start the next auction. Again, you could have a more complicated one where you could actually complete the auction, send a message to the environment, and then the environment could trigger it. Again, this is a design question. So we go, and what we're actually going to do is start the next auction. And if you recall, it tries to figure out how many auctions are remaining, and if there's more than 0, then it continues. So that's the code. It's not as complicated as it looks, although it is. It's there, you get used to it. So, okay. So now, how do we actually run this? So at least in the Mac version, you'll do it this way. So you'll go into we're already in the mTree auction examples, and so what happens is you actually need to be in the folder where the MES and the config folders are. So in this case, we're going to be in the sealed bid common value auction folder, right? So then now the system will be aware of kind of all the files there. And so, again, this is different than a normal Python script. So what we're actually going to do is we'll use this tool called mTree runner. So uppercase T, rerunner, -I, and then we're going to pass it a configuration. So we do -I, and then we just give it a relative path to the configuration we're going to use. So what will happen now is this mTree runner will boot up. And so this will go in and it'll make mTree available. In a second, you'll see a prompt. It's doing a bunch of things on the back end to set up the system in which the agents run. This will tell you the current configuration. There's more stuff we'll be adding to this, and you might notice it later, but that's that. And then once you're in the prompt, you'll type in run simulation, so run_simulation. So you'll hit this button. You'll see a bunch of messages go back and forth. There's a web tutorial we'll be going over that'll have a different way to look at this, but for now we'll use this. So at this point you've run your simulation and you can start to analyze the results. So what you'll do when you're analyzing the results is you'll actually go into, and once you are done, you'll actually be able to go into the experiment log file, and you'll get there's different options for the line formatting, and again we'll kind of talk about those at a later date. But so now these are the log messages that we asked to log, and so in this case, right, we're showing information about the actual sequence of events. And again, the logging is kind of it's up to you to determine how you'd prefer to do that. But in this case, right, we see that we're running a number of auctions. We receive a bid, 33, so on and so forth. So these are the bids coming into the institution. We notice that in this case we have a winner who bid 39. Again, we didn't, we'd have to actually think about it. This perhaps is actually clearer, right? So the winning bid was 39, the real value is 35. And so you can go through and see this over and over, kind of variations on this theme. So that's how you run a basic auction in the system. Will be, like I said, we have a web interface. We're going to put together a set of videos for that. that should make some of this a little bit easier. But that's kind of how you do it. And again, if you run into questions or issues, please let your instructor know. And then also feel free to make use of the issues section on GitHub. So if you're not familiar with that, if you go into the mTree repository, and if you have an account on GitHub, of course, you can actually go into issues and then create a new issue where you could tell us that there's some kind of problem. So a lot of these are actually from last summer. But anyway, that's that. So hopefully that helps, and hopefully you'll see more of these in the not too distant future.